Hello everybody. In this video I am going to talk about the dependent sources. Strictly speaking, there are two kinds of sources that we deal with in electrical engineering as circuit elements. One is a current source, another is a voltage source, and these sources can further be classified as independent sources and dependent sources. Okay, so here in this particular video I am going to focus on the understanding of dependent sources. So here again, independent sources, we again deal with two kinds, two modeling. One is a dependent voltage source, dependent voltage source, and the second one is dependent current source. Okay, we will deal with one by one. The very word dependent indicates that the specified magnitudes of the voltages and currents of the sources are dependent on other quantities. They are dependent on the other quantities like currents and voltages in some part of the circuit. So, we will go ahead with the definition of a dependent or a controlled voltage source. A dependent source is also called a controlled source. This is another word for it, controlled source. Both mean the same. We will go ahead with the description of each one. We will first talk about voltage controlled. We will first talk about a dependent or a controlled voltage source. Okay. So, we will deal with dependent. I will take this color. Okay. Dependent, or I'll use this word, or controlled voltage source. A controlled voltage source basically is similar to an independent source, except that the voltage across the source terminals is a function of other voltages or currents in the circuit. So, the representation of such a source instead of a circle is a diamond. You try to represent a controlled source as a diamond shaped. So, the representation goes this way. This is how we represent a dependent source. We may put a positive, negative, and we may put some value here. Okay, this is how a source is represented. If I need to write the definition, it's preferable write, because when you read it, you will be able to understand it. Okay, it is we can say similar to an independent source except that the voltage across the source the voltage across the source terminals is a function of other voltages or currents in the circuit. All right. So, the words that are to be understood or underlined here is voltage across the source terminals is a function of other voltages or currents in the circuit. It depends. It doesn't give out the energy at the specified value always. So the magnitude itself would vary. So correspondingly, whether the source voltage depends on the voltage of the voltage in the other part of the circuit, or it depends on the current in the other part of the circuit, we have further classification. We have two kinds now. The first kind of a dependent voltage source is a voltage controlled voltage source. Voltage controlled voltage source. It is a dependent voltage source, but the magnitude of the voltage source, the magnitude of the source voltage depends on the voltage in some part of the circuit. Alright. So it is simple. We can write the definition of this also, and how we can understand this. We can take an example and see. This is a voltage source. We can write the definition. This is a voltage source having a voltage equal to a constant times the voltage across a pair of terminals, elsewhere in the network. Okay. So this is how a voltage controlled voltage source can be defined. Now to understand this definition, we will try to consider a network of this nature and see its we can do its understanding. We can understand the voltage controlled voltage source. We will try to take up this example and see. Alright, I am showing a dependent source. I have to remember that a dependent source is represented by a diamond and not a circle. Alright, this is how voltage controlled voltage source is. Where is the voltage controlled voltage source? I will show the voltage controlled voltage source here. I will use this color, I will use positive, negative. This is my, I can even put it inside. What I mean is, I will write it this way. This would be perhaps a better representation. I'll write it this way. Okay. This is my positive, this is my negative. I will show this as plus minus, this is my Vx. And here I will show this as 2 times Vx. And what is this? This is your voltage controlled voltage source. This is a voltage source. The magnitude of this source, or the terminal voltage of this source depends on this Vx, which is the voltage across this particular element. This particular voltage Vx decides the magnitude of this voltage, which is the source voltage. Alright, so this is how we understand a voltage controlled voltage source. Okay, I will erase this part because I don't need it. I'll erase this part, I'll erase this extra thing that I have written. Alright, so this is how a voltage controlled voltage source can be represented symbolically. We abbreviate it as VLVS. I mean VCVS. VC is voltage controlled voltage source. Okay, so a voltage source can be either controlled with the help of voltage of some part of the circuit or the current. So obviously we have taken The voltage here, voltage controlled voltage source we have done. Now we will try to deal with voltage controlled, current controlled voltage source. The second is category of voltage sources, a dependent voltage sources, current controlled, I am using this color, right? I will use this color, current controlled voltage source. This the dependent source that we are going to talk about is a voltage source. The magnitude of this is controlled by the current in some part of the circuit. Alright. So, we will try to write the definition first, then try to understand this with the help of a diagram. Alright. So, here if we have to write the simple definition, a current controlled voltage source is a voltage source. This is a voltage source. This is a voltage source having a voltage equal to a constant times the current through some other element, in the network. Okay. The words that are of importance here is it's a voltage source having a magnitude equal to constant times the current through some other element in the network. Hence the name CCVS. Alright. Here the gain parameter, the multiplication factor is called, the constant that we have called is a multiplication factor. It is also called the gain parameter. Okay. So, we may have to be careful with the units of the gain parameter, we will come to that later, but right now we will write the diagrammatic representation. How do we represent such a source? If we have to understand it little elaborately, we will try to look at this network, which is written in this manner. I am writing some random arbitrary network I am trying to write. There is no specific configuration as such. This network is something that is with the help of which I am trying to just depict what we mean by a current controlled voltage source. Alright. So, I will put this line will clear, maybe I will write the line little differently, this line also will clear. Now, I will write these two lines little properly, then okay, not bad anyway. I am going to take little time in drawing these networks. Alright, I have written the network. Here I will show the various things. Suppose this is my source, dependent source with this as the polarity. I can write this as, let us say, some alpha times Ix, where this is my Ix. The current in this element I designate it as Ix. Okay, there are currents in other parts of the circuit. Now, this alpha time Ix is the magnitude of the current controlled voltage source. Okay. This current controlled voltage source here in this case has got alpha times Ix. So, what should be the unit of alpha? This should be thought about carefully. The unit of alpha obviously has to be equal to, unit of alpha has to be equal to, what should be the unit of alpha? Because ultimately we need to get volts. Okay, we need to get volts. So the unit of alpha essentially will be ampere per volt. That will be the the gain parameter has the units of volt per ampere. Ampere will get cut, right? So unit of alpha obviously has to be volt per ampere. Okay, the gain has to have a unit of volt per ampere. When it gets multiplied with Ix, which is in amperes, amperes will get cut, will get cancelled out, and the unit of CCVS or the current controlled voltage source will be in volts. All right. So we have to be little concerned with the units also, or we should know what exactly we mean by, what exactly is the unit of these gains. We have to consider that, we have to take this into account. Now further on, what other kind of source we have? The second category is dependent current source. So we will take dependent current source. So the second category is dependent current source. This essentially is a current source. This is a dependent current source. How do we define this? So a dependent current source is that source where the current flowing through a dependent source is determined by the current or the voltage elsewhere in the circuit. It is as simple as that. The magnitude of the current source or the magnitude of the current that flows out of this source depends on the voltage or the current elsewhere in the circuit. So we need to write the definition. It is similar to an independent source, independent, we can even put current source, independent current source, except that the current through the terminals is a function of or is dependent upon is a function of voltage or current in some part of the circuit or elsewhere in the circuit, in some part of the network. All right. This is how we define a dependent current source. So depending upon whether it is the voltage or the current that defines the magnitude of the dependent current source, we have two classifications. We have two kinds here. We have two kinds. Number one is voltage controlled current source, and the second one is current controlled current source. We will first write this VCCS, voltage controlled current source. Okay. So here also it is a simple thing, voltage controlled current source. What do we understand by voltage controlled current source? So the current through the device or the source, current through the terminals of the source depends on the voltage in some part of the circuit. Okay, it is the current depends on the voltage. I'll put it in short. Source current depends on the voltage elsewhere in the circuit. Okay. If I have to represent it by means of a diagram, we can do that easily. This is a source. This is a current source, you may have to remember. This is not a voltage source, this is a current source, but the magnitude of this source depends on the voltage in some part of the circuit. I will take a simple example like this. Okay. Let me say that this is a current source, this is a current source, and let us say the magnitude of the voltage here is Vx plus minus, let me say this is beta times Vx. Okay. This is beta times Vx. Okay. So, Vx is in volts. So, what should be the unit of beta? Units of beta. What should be the unit of beta? This is some constant. Beta is some constant. All right. So, you have to get current, right? So, Vx is in voltage. Okay. So, beta should be ampere per volt. This is the unit of beta. So, when ampere per volt gets multiplied with volts, you will get amperes. All right. So, this is a voltage controlled current source. Okay. The magnitude of this current source is dependent on this voltage Vx. Hence, the name voltage controlled current source. All right. Let us talk about the other category. Current controlled current source. We will talk about a current source, a dependent current source, or a current controlled current source. This is CCCS. All right. A current controlled current source. How do we understand a current controlled current source? It is simple. The current through the source in this case is a function of the current in some part of the circuit. All right. It is dependent on the current in some part of the circuit. So, how do we will write? Okay. The current through the terminals of the source is dependent on the current in some part of the circuit or of the network. Okay. If you want to understand this, I will try to write a diagram so that you will be able to appreciate how the magnitude of the source current depends on the current in some other part of the circuit. Okay. This is my current source. Let me talk about a resistance and an impedance. One impedance here. I will put another element. Let me say here. Okay. I will try to take this element. I will copy this element, paste this element, take it here. Alright, I will try to write magnitudes. How do I write the magnitude? If I call this as, let us say, some 2 times Iy, this is the magnitude of this current source. Obviously it has to have a narrow inside the diamond symbol, and this Iy, where is this Iy? It could be the current here. It could be the current here. The current here in this branch, which is Iy, determines the magnitude of the current source, or magnitude of the current that this dependent source is letting out of its terminals. So here obviously this constant 2 is unitless. Alright, so this is how we understand the dependent sources. You have plenty of examples for all these things. You have your for controlled sources, if you talk about examples, you have got several examples in real world, such as your electronic amplifiers, your transistors, your transformers, your electrical machines. There are plenty. They are all controlled voltage sources or controlled current sources. Okay. So examples can be examples of controlled sources. You have devices like amplifiers, electronic amplifiers. You have your transistors, even transformers, and electrical machines. So you get to see all these things in in all these devices. You get to see control sources. Okay, so you may need to do a modeling of control sources. That is when this kind of representation comes in handy. When you need to model your transformers, you need to model your transistors, amplifiers, machines, etc., etc. You need to know how to do the circuit modeling of these dependent sources. So that is the importance of dependent sources. All right. So this is a supplementary video that supports our curriculum. All right. Hope this is clear to you. Thank you.